So, on the blackboard, you are seeing an problem. This problem is based on the previous video. That is based on the superposition principle. See, it is example number 1.5 and it is in page number 10. Come on, let us go through the problem. Consider 4 equal charges Q1, Q2, Q3 and Q4. And all these forces are equal to Q and the magnitude of the charges is equal to 1 microcoulomb. So here I am writing the given quantities are Q1 is equal to Q2 equal to Q3 equal to Q4 is equal to 1 microcoulomb means it is 10 to the power of minus 6 coulomb. Located at 4 different points on a circle of radius. So this distance we are considering it as 1 meter as shown in the figure. What is the total force acting on the charge Q1? Let us consider the total force on Q1 as F1, or I can write it out as F1 vector. I have to calculate both magnitude and direction. So what is that F1 vector I have to calculate? So how to proceed with this problem? If you are considering this problem, again I am drawing this diagram here. So I am writing the solution and I am considering this diagram here. I am having a circle. This is the x-axis and let us take this as the y-axis. Here I am having the charge Q2. Here I am having the charge Q3. Here I am having the charge Q4 and I am having the charge Q1 here. You see, the charge Q1 is experiencing force due to Q2, due to Q4 and due to Q3. If it is due to Q2, then the force will be acting from here to here. So the force will be acting in this. So the direction of the force, you can consider this in this direction. When you are considering the direction of this force Q2 on Q1, it will be acting along this. So let us consider this force as F1, 2 vector. Similarly, if I am considering this Q4 on Q1, I can able to get the force along this direction and I am writing this as F1, 4 vector. Then due to Q3, I am getting a force along this direction and I am writing it as what? I am writing it as F1, 3 vector. Now, this force on Q1, that is force, or I can say net force on Q1 is equal to vector sum of individual forces, that is F1 2 vector plus F1 3 vector plus F1 4 vector. Now you see, let us calculate this F1 2 and F1 4. This F1 4 and F1 2 are inclined at an angle theta with the horizontal, and this theta will be equal to 45 degrees because angle between these two is equal to 90 degrees. So I can write this is the horizontal line, this angle is equal to 45 degrees. So theta equal to 45 degrees. First thing. The second thing, if you are considering F1, 2 vector, this is acting along this direction. So how to add? You resolve F12 vector, okay, you resolve F12 vector into two perpendicular components, one along the horizontal and another one along the vertical. You see, this F12 vector can be resolved one along this horizontal direction and another one along what direction? Another one along this vertical direction. See, this vertical direction is opposite to this theta. So this vertical component is F12 vector multiplied it with sine theta. What is this? This F12 horizontal component is adjacent to this angle theta. So the horizontal component is F12 vector into cos theta. Similarly, what you do is you consider F14 vector. You consider F14 vector and resolve this also into two components. Resolve this into two perpendicular components. How you can able to resolve it? When you are considering F4, again you can consider the horizontal component and another one along the vertical direction. So the horizontal component, and when you are considering the vertical component is, see, horizontal component is adjacent and the vertical component is opposite. So vertical component is F14 and it is F14 vector sin theta since it is opposite side, and horizontal component is F14 vector cos theta. Now see, I am drawing the diagram here again. See, this is the charge Q1. On this, along the horizontal direction, I am having F12 cos theta, again F14 cos theta, and also along the same direction, I am having F13 vector. Along the vertical direction, in the downward direction, you are having what? F12. So I can write F12 vector sin theta, and along the vertical upward direction I can write F14 sin theta. See, from this diagram you can see both vertical components are equal in magnitude and opposite in direction, or equal in magnitude and opposite in direction. So they cancel each other. That is the net force is not contributed by vertical components. Only the horizontal components added up. To give the resultant. You see, when you are considering this see, I have told you the vertical components are equal and opposite. F14 and F12 are equal because charges are equal and the distances are equal, and F1 theta is also equal. So this F14 sin theta and F12 sin theta, since they are equal in magnitude, opposite in direction, they cancel each other. Now let us calculate what is the net force then. F12 F1 vector is equal to, then that is net force. So net force is equal to F1 vector is equal to F12 vector cos theta plus F13 vector plus F14 vector cos theta. Direction along horizontal, or I can write along x-axis. That too I can write it out as positive x-axis or plus I cap I can write. See, I can consider the value of F12, F13 and F14. You see, I will be considering the diagram again. Here the circle, the radius is considered to be 1 meter. So diameter is considered to be 2 meters. Here Q2, here Q1, here it is Q3, here it is Q4. If I am considering F13, okay, if I am considering F13, so I can write 1 divided by 4 pi epsilon 0 into Q1 into Q4 divided by this distance R3 1 square. Along positive I cap I can write this. So what is its value? 9 into 10 to the power of 9 into Q1 is 10 power minus 6, Q4 is 10 to the power of minus 6 whole divided by, what is this R31? R31 is this distance. It is the diameter, so 2 meters, so 2 square. So you can simplify 9 divided by 4 multiplied it with 10 to the power of minus 3 Newton along the positive x-axis. Take this as equation number 1, or you take this as 2 and take this equation as equation number 1. Similarly, you calculate what? Similarly, you calculate the next one, that is F12 cos theta. F12 cos theta. What is this value? See, again, F12 is 1 divided by 4 pi epsilon 0 Q1 into Q2 by, what is this distance? This distance is Q2 to Q1. So I can write R 2 1 square multiplied it with cos theta. Simplify by substituting it 9 into 10 to the power of 9 multiplied with 10 power minus 6 into 10 power minus 6 multiplied with cos 45 whole divided by, what is this? R21 the whole square. What is this distance? You apply Pythagoras theorem. See, this is 1 meter and this is 1 meter. From this center point, this distance is 1 meter, this distance is 1 meter, so this distance is root 2. So I can write root 2 the whole square. So get the value. I can write here. See, 9 divided by 2. What is cos 45? 1 by root 2. So 1 by root 2 I can write here as another root 2 multiplied it with, see, 10 power minus 12 into 10 power 9, we will be getting it as 10 power minus 3 positive x direction, so I cap, and in terms of Newton take this as equation number 3. So this value I can consider this as F12 cos theta. Then I will be going for the next one. What is the next one? I am writing F13 cos theta, not F13, F14. Sorry, F14 cos theta. Again, 1 by 4 pi epsilon 0 Q1 Q4 divided by R41 square into cos theta. What is this value now? It is again 9 into 10 to the power of 9. Q1 is 10 power minus 6. Q4 is 10 power minus 6. Cos 45 divided by. Again, what is this distance R41? The distance from 4 to Q1, Q4 to Q1. Again, it is root 2. So, I can state that root 2 the whole square. Simplify, you will be getting 9 divided by 2 cos 45. Again, you can write it out as root 2 multiplied with 10 power minus 6, 10 power minus 6, you will be getting it as 10 power minus 12 plus into 10 power 9, you will be getting it out as 10 power minus 3, then I cap n. Consider this as equation number 4. So, take equation 2, 3 and 4, substitute in what? Substitute in 1. You consider the equation, the value of 2, value of 3, value of 4 in equation 1. So, the next point, I am writing it here. Substituting the values of what? Substituting the values of 2, 3 and 4 in 1. So, you write substituting 2, 3 and 4 in 1, we get the net force on Q1. Net force on Q1 is F1 vector is equal to, what is the equation number 2? You see, equation number 2 is 9 by 4 into 10 power minus 3. So, I am writing it here 9 divided by 4 into 10 power minus 3 plus equation number 3, it is 9 divided by 2 root 2 into 10 to the power of minus 3 plus again equation number 4, 9 divided by 2 root 2 into 10 to the power of minus 3. All these acting along the positive x-axis. So, I can write it out as I cap Newton. So, you try to solve it out. It will be easier for you to solve. See, I will be saying the method and you just solve it out. Okay, now F1 vector is equal to, see, first of all I am taking 10 to the power of minus 3 as a common factor. Then here I am writing it as 9 by 4 plus, here you see I am multiplying and dividing I am multiplying the numerator with the root 2 and denominator with the root 2. If I am writing it so, 9 into root 2 divided by, in denominator if I am multiplying it with the root 2 into root 2 is 2. 2 into 2, I will be getting it as 4. Plus, the same concept here, 9 into root 2 divided by 4 and then you put it out as I cap Newton. Now, it is very simple. You yourself can simplify this. 9 by 4, take it out as common into 10 to the power of minus 3. We will be getting 1 plus. Instead of root 2, 1.414 plus another root 2, 1.414, and you can write it out as I cap Newton. Come on, you get the answer, and your answer will be in terms of Newton, and you solve it out. It is just addition and then multiplication. It is for you to work it out. I think you are very clear about this problem. In your book they have gone in another way, but it is the simplest way where you can solve the problem. So try to solve the problem and get the answer. All the best.